Welcome, everyone. This is All-Minus-One, and my name is Bill. Hello, hello. So, and continuing on before I took a long hiatus, we're going to talk about some diet stuff today, health things, more or less. Not so much a diet, but what causes you to age? And there are many factors. Um, but specifically, animals with the lowest levels of insulin and often lower metabolic rates live quite long. So we're going to look at some stuff with that. I'm going to stick to about an hour. That's the plan for the week. I'll be back tomorrow. And like I said, just hour streams for these guys. So apologies if you want something longer. I don't have the time right now. On Sundays, that's what Sunday is for. And I'm going to look around, maybe get someone to come on the show this coming Sunday as well. So maybe I'll figure that out later today and be able to let you guys know tomorrow. In any case, before we get into it, of course, I have to shill and grift and all that stuff. There are links in the description if you wish to go over to Entropy and send any sort of paid chat. You can do that, or of course through PayPal. I'm not going to be checking PayPal during the stream though, so if you guys want to send me a message over there, I'll look at it, of course, but it's not going to be live like Entropy is. And of course, there is a Odyssey link down there, and I want to get my Odyssey page up a little bit because I want to be able to live stream there. So if you're not subscribed to me over at Odyssey, please do that so I can get that going. And of course, I am on YouTube, Entropy, and DLive as well. So anyways, let's get into it, guys. So why the rockfish can live for centuries and you can't? A genetic study delves into the secrets of how some rockfish live and die like normal fish after, say, a decade, and some swim on for over 200 years. Now, I'm going to kind of use this article. We're going to start here as as kind of a jumping off point. Hopefully, I can get through this pretty quick, and then I'll show you some papers, some science, some sciencey stuff. But hopefully, I can read this pretty quickly. Consider the rockfish, a family of ray-finned sea perch that belongs to the great fish family of scorpionfish. The range of rockfish coloration and shape is stunning, and so on, as it turns out, yada, yada, yada. We got Spook here. So it seems like my Lord God wanted me to be here because I started sleeping 5 hours ago and randomly woke up just to see you streaming. Well, that's cool. We're not going to be talking about religion today, just health, just some health stuff, some things you might be interested in, especially this world that teaches so much anti-health stuff, which I should be getting into today. By the way, folks, if I'm a little off today, I'm kind of tired. Last night on the It's Just for the Memes, I had some beer, which wouldn't be a problem, but it was stronger beer than I'm used to, and I don't really drink anymore either. So, but on occasion. So today was rough. This morning, that is. So let's get down to where this is important. Basically, some of these rockfish live for 11 years, some of them 200. The oldest known rockfish was 205 years old, as we are unlikely to have encountered the one that has lived the longest, right? The inference is they can live longer than that. The question is how they do that. And the fish's age shouldn't be estimated by size, which is affected by nutrition and environmental circumstances. Yada, yada, yada. We don't need to read all that. I'm trying to get to the crux of this. Expert fish observers note that counting otolith rings is an art in itself. Okay, we're still talking about age and all this, but again, they roughly estimate it. I think here is what I'm trying to get to. Anyway, given that humans are so obsessed with living long, An international team of researchers sought insight into rockfish DNA is since I'm not going to be able to read that true theoretical inevitability as theoretical work has been concluded for decades. Why does a pig in my go by flash in and out this dark void about 5 weeks, while some rockfish live a couple of centuries and colossal Greenland sharks may pass 400 and possibly 500 years. So the question is why? Why do these animals live so long while others basically expire so quickly? The shark also matures very slowly. What the team inquired are a genetic underpinnings of extreme lifespan. So the team sequenced the genomes of 102 fish from 88 rockfish species, hoping for a glimpse at the genetic adaptation that influenced lifespan and vertebrates, and they did find. It says from here to forever mole rat style. So this is going to talk about mole rats for a minute and their long lifespans as well. One key adaptation for extreme longevity is DNA repair. In all living beings, DNA is under constant attack. It gets degraded, but we living beings have enzymes that can fix it. And actually, more importantly, are the telomeres, and they tend to get shorter as we age. And there are a lot of things you can do to keep your telomeres longer, potentially, or at least what we see in people who age very well. They tend to have more stable DNA, and their telomeres tend to be more intact. So, of course, things that damage your DNA are lack of proper nutrients, environmental toxic exposure. You have all kinds of that if you lived in the industrial world, um, and your body not being able to properly detoxify itself or heal itself for whatever reason. Cancerous cells, of course, you guys probably know happen. They occur all the time, but your body takes care of it. It eliminates the cancer and throws it out in the rubbish. What's up, Big Nick? So, uh, but these rockfish have special DNA apparently as well. So there are a few other factors they throw in here. Note that this isn't about mutation, changes when DNA is replicated. This is about mishaps, which can be repaired by cellular process to identify the damage and correcting it. Radiation, for example, damages DNA by causing the molecule to break. Free radicals also harm DNA by causing breaks and other damage. Now, what causes free radicals tends to be, again, lack of proper nutrition and particularly high inflammatory levels. These things tend to do lots of damage to your body as well. So that's some of the stuff we're going to get into. What's really cool about rockfish is that they are many different long-lived species. We found that while all of these long-lived rockfish exhibit signatures of positive selection and genes encoding for DNA repair enzymes, different genes are under selection for different long-lived species. And he says it's convergent evolution. In other words, various long-lived rockfish species have enhanced DNA repair mechanisms, but not necessarily the same ones. That indicates they didn't inherit the trait from a common ancestor, but the different rockfish developed the adaptation on their own. So this is just like probably epigenetics at work, but we're going to call it evolution. So, anyways, yes, their DNA is more robust than yours. And yes, who else has this trait? Our friend, the naked mole rat. These tiny bearskin burrowing rodents, a few of which could fit in the palm of your hand, can live for decades. And if you guys don't know anything about zoology or anything, generally speaking, animals are larger when there is more land mass for them to have to occupy. So if you take animals that have high density of population, they tend to be smaller because of lack of resources, right, and food. Animals on islands, smaller islands tend to be smaller, those kind of things. But also the size of the animal also often correlates to their lifespan. Larger animals tend to live slightly longer, but it's not a 100% rule. Better DNA repair can also lead to not getting cancer. Submat says, and yes, cancer is all about unknown in the naked mole rat, meaning the mole rats like basically don't get cancer. So they got like super genetics. This should tell you a state about your genetics and our environmental loads and toxins and what we eat, because cancer is quite common in most people. And I don't mean as I was speaking of a minute ago, but I mean as that most people, if they live long enough, will get cancer, and that's probably how they're going to die if it's not of heart disease. Both of these things, again, are highly linked to insulin resistance, by the way. So, and we'll get there. Another contribution seems to be the genes called bitrophilians, or however you pronounce that help fight chronic inflation, which has been emerging as a key therapeutic target in humans. The team believes these genes are related to the extreme longevity of the relevant rockfish. The team also lists genetic adaptations that enable extreme longevity, excuse me, by influencing insulin signaling, and others that influence size and adaptations to depth. So they're influenced by insulin signaling, right? And the adaptations to the depth in the ocean. Or are we talking about, or these are talking about the rockfish? So, but they think that the same mechanism might be in part with the mole rats, as well, as the article will read here in a bit. Mutation in insulin signaling pathways are often found in long-lived species, the scientists note. And they are in the rockfish. Insulin is a hormone that regulates the metabolism of the carbohydrates, fats, and proteins we eat. It's complicated. Insulin also activates and house cleaning cells of the cell from protein aggregates. Nobody wants those cluttering up one's cells. It does many things, but its primary action as a hormone is to flush things into the cells. It moves things along, essentially. But your body has receptors that hook up to it. It's how most things work in your body. And those receptors can basically get dulled. They need more insulin every time you go to eat or whatever to get the nutrients pushed in. And this happens through basically not doing the things that we properly need to do, clean out our system, like fasting. Like, you need to fast regularly. It should be part of your life. You don't need to eat all the time. And again, we'll talk about that. And if I don't get this finished this week, I have several articles. We'll talk about it for a few weeks. So, Spook said the thyroid also degrades generally, leading to a less effective immune system and a higher chance of autoimmune disease. Sure. But again, that's generally because of environmental toxins and the not getting appropriate nutrients. For instance, iodine is needed for proper thyroid function, right? That's pretty basic stuff. And that's why they give you iodized salt. No, I don't use iodized salt, but I use like natural salts myself, Celtic sea salt primarily. But I do take just a little bit of seaweed, kelp, dried, and I make miso and put it in bone broth I make, and yeah, it's pretty good, pretty good, and it's like a ridiculous amount of iodine because of that. So, it's just like little things you can do, you can implement in your life and make sure that these things, without having to take like a bunch of multivitamins and stuff, just eat regular food, things you might like. So where was I at here? How exactly does all this connect to extreme longevity? There is much we still don't know about how this regulates lifespan. Though, to be honest, well, what's your article about that, man? The researchers also observed that long-lived rockfish species are less genetically diverse than the short-lived ones. One area where the rockfish and the mole rat defy the odds is size. Across the tree of life, we already know some interesting things about lifespan. Generally, the bigger the vertebrate, the longer it lives. Elephants outlive mice, like I was talking about earlier. This is far from being the rule. By and large, Chihuahuas outlive Great Danes, and so do cats, and rockfish aren't particularly big. But the researchers did identify genes that enable the rockfish to grow larger and tolerate extreme cold in the ocean depths. Cold's cold's an important thing. And this thing doesn't get into the mechanism. I wasn't planning on talking about cold today, but I'll address it. Uh, in that you have brown fat stores in your body. You're born with them, but you can actually use brown fat and develop more of it through cold therapy, and it's metabolically active. White fat that's used basically, why most of us when we get fat are fat, it's white fat, it's not brown fat. Brown fat's deep inside your tissues, amongst your organs, and in certain areas, it's padded around your spine and stuff like that. So these these brown fat areas actually uh, create and burn energy. I'm using burn colloquially. It oxidizes. It doesn't burn it, but yeah, they're metabolically active. The other fat stores that you have are just meant to be stores of food. So cold activates these and increases them. It's really interesting because I believe the article goes on to mention oxygen deprivation, hypoxia, right? And there's plenty of study all the way back from Butinko. Now I've known this because I did Russian martial arts and stuff. Um, you know, man, since 2005. So, um, eh, but a lot of these things are newer to the West. But breathing techniques and oxygen deprivation can actually bring about certain amounts of longevity. When Wim Hof right now is quite popular because of that, and his techniques, his methods work. I use them. They're they're amazing, and you feel great. But you're getting a release of adrenaline and other stuff, and that he is able to actually regulate and control his body temperature through his breathing methods. So that's pretty sweet. Spook says no. Actually, the thyroid degenerates even the best of circumstances due to the fact that thyroid cells don't. Oh, okay, okay. It doesn't regenerate. I didn't know that. But you know, we all degenerate. We basically hit 25, and it's all downhill from there. You're at your peak of growth and everything at 25 is when your prefrontal cortex, all your synapses are finally, you know, fully formed, and then you just start dying the rest of your life. So that's the sad reality. From a Christian perspective, I would say that the new body, the resurrected body, from just little things that were mentioned in the Bible, is probably not quite a normal flesh body, um, like we would think of it, but it said that Christ looked different to the people. They didn't quite recognize him initially. He was in this glorified state. So you'd have to assume that all of the bad genetics and all the things that make us age and they're killing us, all of the disease, all the you know, our genetic flaws would be fixed. And that's probably why he would look different. That's at least to my mind, right? In any case, let's get back to this. I don't need a rabbit hole any more than I normally do. It has been separately observed that slowing down your metabolism by being cold, for example, allows you to live longer. This has birthed a new genre of sci fi wishful thinking. While influencing insulin signaling can directly influence lifespan, cold and depth tolerance genes indirectly enable the fish to live longer. It bears adding that the rockfish would have likely evolved these cold and depth tolerances traits for the sake of survival. Yeah, whatever. Also, the long-lived rockfish obey the command to be fruitful and multiply relatively late in life. They get older, and ladies produce more and more robust youngsters. This is actually somewhat true for human beings. Back in ancient Greece, they bred the women around, um, I think, as young as 14, they would marry girls off and get them pregnant and all this stuff. And the Spartans had the practice of waiting to their girls, I think were in their early 20s, if I remember correctly, and like 19, 20. And that was like the prime birthing age for them. And they had less malformed children that way. And you'll find this a lot in a lot of ancient cultures that the traditions of getting when a girl can get pregnant or when she should get pregnant is at a certain time for having strong, beautiful children, right? And we're talking like when I get into like Weston Price's work and stuff like that, like he examined these folks' teeth. They had no dental decay, they have no heart disease, they have no cancer, live primitive lives. They eat a lot of meat generally, and they're quite healthy. They have no need to take their wisdom teeth out because their skulls and their jaw lines developed appropriately with the proper nutrition. K8 said, "There's no such thing as God. Think again." I'm sure when you meet God, he'll disagree with you. Also, the long-lived rockfish obey the command to be fruitful. Yeah, yeah, yeah. Read that. These fish just get better with age. The Washington-based National Oceanic and Atmospheric Administration observed, explaining the bigger the female, the better the chance it has energy to reserves to sustain production during difficult times. Also, long reproductive lifespan increases the chances that some young will be born during good years. Okay. Anyways, DNA repair aside, can other parallels be drawn with a naked mole rat? That little guy, to the amazement of scientists, um, invices no signs of aging during its decades of burrowing until it flops over and dies. I think there are many possible parallels. Perhaps the biggest parallel is the scenario in which extreme lifespan evolved. Once the rockfish reached maturity, it has few predators. This is similar to subterranean mole rats. It seems the scenarios of extreme lifespan to evolve are those in which species are able to avoid predation. Um, and that's important because, we're top of the food chain. I think he said, yeah, here it is. It says here, it was also demonstrated that their life in burrows under conditions of low oxygen, high carbon dioxide, and asexuality, only the queen breeds. That's pretty interesting. Also keeps their metabolic rates low and extends their lifespan. Pretty interesting, right? Anyways, so that kind of gave me a primer to talk about a few things off the cuff. And then, we can go over here. I do have a couple other articles that maybe we'll get to, this one particularly, want to live longer, you may have to fast every day. And this is a article that I haven't looked over yet, but is basically saying fasting versus calorie restriction. Calorie restriction was for a long time the model used that people who wanted to extend their lifespans used. And you meet them and they're all basically anorexics. Most of them, a lot of them are vegans. They're not getting proper nutrition, and protein is vital. And so we talked, and this is kind of where I'm going with this. We talked about insulin being a big thing, and some people are worried about protein consumption, right? And it's really not a problem. If they worry about the kidney thing. I've shown you before in the first video I think I did with Alabastard about how there's no evidence of that. Um, but protein does up blood glucose. It will affect it. It will make it rise, not necessarily as much as carbohydrates, but if your blood glucose goes up, then insulin is going to be released. So it says insulin is required for carbohydrate, fat, and protein to be metabolized. With respect to carbohydrate, from a clinical standpoint, the major determinant of the glycemic response is the total amount of carbohydrate ingested rather than the source of the carbohydrate. Now, there is one thing that should be clarified here. Fructose does not. Fructose does not work through the insulin pathway. It goes directly to your liver. And now I think that an abundance of fructose without other types of sugars It's probably a bad thing. It's probably not how things are supposed to operate. But if you recall, the last video I talked about diet. I think it was the last. No, I talked about calories in, calories out. Before that, kind of like the general idea of what we should be eating. What did primitive people eat? They ate meat and they ate fruit. And this is pretty much what they ate. And then, as they got more agrarian, they might have grains and stuff because it's an easy, cheap way to get food, energy, calories, but it's not as nutritionally dense. So, um, there just seems to be just an overwhelming amount of evidence to my mind that fructose in fruit isn't necessarily bad, but when you isolate it, like high fructose corn syrup being in everything, it becomes bad, and then you get things like fatty liver disease. So another way you can guard against that too, guys, is by getting botan in your, however you pronounce it. I think it's botan, which is a basic um, vitamin you need, essential vitamin, and basically 2 or 3 eggs every day will take care of that, as long as you eat the yolks. You tend to get that in like red meat and liver and stuff as well, but of course, way more in something such as liver. So it says this fact is the basic principle of carbohydrate counting for meal planning. Fat has little, if any, effect on blood glucose levels, although a high fat intake does appear to contribute to insulin resistance. It can, but it's usually in the present with sugars, and that's the Randall cycle. And I will make a probably very detailed explanation of the Randall cycle. Basically, when you're eating fats and carbohydrates together at the same time, your body starts competing for those nutrients and then it allows nothing to get in. And then your insulin levels continue to go up. So it makes you insulin resistant. And then the other thing is you're not getting the nutrients at immediately or easily. So you tend to overeat. So it's a totally dysfunctional way to approach your diet. Now there are some people like Bart K, and he may be right. I don't know. He's definitely far more learned than I am, who believe that you shouldn't be switching between sugars and fats either. You should just be all or nothing. Sugars are carbohydrates and fat, that is, but that's what carbohydrates are, is sugar. So uh, it says protein has a minimal effect on blood glucose. Let me highlight that. You guys want to see where I'm at here? Protein has a minimal effect on blood glucose levels with adequate insulin. However, the insulin deficiency, gluconeogenesis, proceeds rapidly and contributes to an elevated blood glucose level. So, gluconeogenesis is the body making its own glucose. This is why there is no essential sugars that you need in your diet, because your body can produce its own glucose. It is not a hyper efficient um, process, but it it does work rather well uh, once you are adapted to not having any sort of carbohydrates in your diet, and it is regulated by your skeletal muscles need, generally speaking. Yes, you did miss most of this, Auntie. Yes, you did, but at least you made the memes last night. So it says with adequate insulin, the blood glucose. Well, hold on, let me back up. Yeah, I read that. Okay. With adequate insulin, the blood glucose response in persons with diabetes would be expected to be similar to blood glucose response in persons without diabetes. And, you know, this is how actually diabetics used to, before the invention of synthetic insulin, uh, they didn't know what to do with diabetics. They couldn't gain weight, but one of the ways that they would control their diabetes generally was to eat a lot of meat and fat. And some doctors will recommend, like my doctor recommended to my father some years ago when he was getting kind of large, to say the least, and he was basically pre-diabetic. He could have been classified as type 2, but the doctor didn't want to give him the diagnosis. He had him go on a low carb diet, and it stopped in its tracks. So yes, confess your sins for wit. Anyways, I'm not going to read all of this paper. It's just to show you that that's how it works, right? Generally speaking. And then here we have the effects of ingestion on glucose insulin response to standard oral glucose load. So you guys can look all this up. It goes up. But this study basically essentially says when you eat sugars with proteins, it doesn't go up as much. So there is all of that. And this is a chart. I got to bigly it of how some different proteins can spike um, your insulin more. So, it's not that big of a deal for most people, I would say. The insulin spikes that are created from sugars tend to last longer. They tend to be a much more dramatic rise. And honestly, that's kind of what you want in insulin. You want it to spike up for a minute and then drop off immediately. That means you're highly insulin sensitive. If it spikes up and it flatlines, it stays there for a while, that's not good. Not generally. It means that your body's not getting the nutrients and it means it's highly insulin resistant. So see if I put this in dark mode. All right. If I put this in dark mode, I have to read it on my second screen. But if I don't, it's hard for me to read that text. So I'll read from across the way. It says, in fact, a July 2007 article published in the Diabetes Metabolism Research and Review showed that whey protein resulted in a higher after meal amino acid concentration and a greater insulin response than casein. Casein is, of course, it would, because whey protein takes about 2 to 4 hours to digest, and casein takes, like, I think 6 to 10 or something like that. So, yeah, it's going to spike your insulin more because it's going to start digesting much quicker. A similar study conducted in 2011 concluded the daily intake of at least one high protein meal, especially whey protein, consumed on a low to moderate amounts of carbohydrates increased insulin release and lowers blood sugar. But still, research has shown that 35 grams of casein is enough to spike insulin after an overnight fast, and this insulin spike from protein occurs very quickly after protein intake, typically reaching its peak levels at about 15 minutes after ingestion. And this is just different foods, right? So you have all bran, porridge, um, muesli. What is that? I don't even know what that is. Muesli, Special K, Honey Smacks, all that. So that's all sugar. By the way, if you're eating cereal, folks, you're eating sugar. That's all it is. If you're eating bread, you're eating sugar. That's all it is. It turns into sugar in your body. And then often it'll be then turned into, if it's not used directly, it could be stored in your muscles if it needs it, but gluconeogenesis will do that alone. And then it gets turned into fat, basically, if it's not used. So, and then you can look at the responses to eggs, cheese. So, and a big part of this too is probably the fat in that beef, and there's how lentils makes it go up. Fish, that makes sense because I can actually typically feel that. Beans is way up, and then fruit and all these other things. So, like I said, there are different effects to insulin, and it might be different to different people. So, one of the ways that we can control this and make ourselves more insulin sensitive is with fasting, and that's regular daily fasting. So we have time restricted feeding benefits, mechanisms, and challenges in translation. So again, I'm just going to read the abstract. I know it's not the best way to look at a study, but I'm going to also um, let some people speak on this here in a minute. phase with daily circadian rhythms induces metabolic. Hold on. Induces metabolic dyssynchrony in peripheral metabolic organs and may increase chronic disease risk. Why does this happen? Well, your body works on circadian rhythms and it has certain times that your hormones ramp up and down. In the morning, for instance, you're the most insulin sensitive then. And it tends to be that in the evening, your body tends to tolerate fattier meals, that, unless you're very fat adapted already. Spook, I'll pause the whole show for you. BRB, okay. Speaking of which, you know what? I haven't even looked over since we're there. Strippy over on Entropy. Am I cute? I don't know what the cute's about. Wow. Bay State over on DLive. Man, just bring that up. Woo. What is up? What is up with that? What is up with the chatters? Anti-commie, I'm gonna have to send you on some missions, dude. So, anyways, where's that here? Time restricted eating is a dietary approach that consolidates all calorie intake to a 6 to 10 hour period during the active phase of the day. I'd say 6 hours is pretty restrictive. 10 hours is pretty good. Again, I'm going to let someone talk on this in a minute. Without necessarily altering the diet quality and quantity. It reduces body weight, improves glucose tolerance. And the reason why is because you're not constantly spiking up your glucose. It's you guys out there, you want to have high testosterone, you shouldn't be grazing all day long. That'll make you estrogenic as hell. It will make your testosterone go down. It's just what your body does. It's how your hormones work. So, just like if you eat, maybe you're different, but for a lot of people, you eat first thing in the morning. The way your hormones are, particularly your levels of cortisol, because your body releases a bunch of cortisol to wake you up in the morning. If you go and eat right away, it might make you more tired, lethargic, right? I'm sure a lot of you have experienced that. That's because of that hormone release. It's just not a good time. You have to wait a little bit, right? Spook says, "Oh, nice. As a Muslim who fasts almost half the week, I get to be more healthy." Yeah, man, it is quite healthy for you. In fact, Ramadan's basically an OMAD style eating pattern, one meal a day, right? So, you're in Christian tradition, they do a lot of fasts too. At least if you're Catholic and Orthodox faith, but they tend to fast more like without having meat and stuff, instead of going full on. But those are things that also came about later because in the DDK, I'm pretty sure it's pretty clear that the fasts that they were taking were full on fasts. So, anyways, so it improves weight, glucose tolerance, protects from um, um, hepat- hepatostenosis, which is your basically your liver going bad, more or less. Increases metabolic flexibility, reduces atherogenic lipids, or sorry, atherogenic, lipids, and blood pressure. Improves gut function because you're not constantly taxing your digestive system, right? And cardiometabolic health and preclinical studies. This review discusses the importance of meal timing on circadian rhythm, the metabolic health benefits of TRE in preclinical models and humans, the possible mechanisms of action, the challenges we face in implementing it in humans, and the possible consequences of delaying initiation of the time restricted eating. So I don't know. Okay. So this isn't the same doctor that has this here, but I will bring this up. This is Dr. Sanchin Panda. And you can find him. He talks to Rhonda Patrick, if you're aware of Rhonda Patrick, who is a dietary doctor, researcher who's on Joe Rogan quite a bit. So she's talked with him several times as well. I believe actually have some of those interviews as well pulled up. But guys, let me know if the sound is not good on this. I'll figure it out.
Apparently, it affects nearly 30% of the population, and doctors say it increases the risk for type 2 diabetes, heart disease, and stroke. However, stay with me, researchers from the Salk Institute and the UC San Diego School of Medicine discovered something that might help prevent that altogether. Here now to talk more about that from the Salk Institute is Professor. We've got Dr. Sachin Panda with us. Welcome.
Hi.
Well, first of all, explain to me what this metabolic syndrome is, because I'm assuming it's not just what happens to women over 40 that our metabolism stop.
No, it's as you said, metabolic syndrome affects almost 1 in 3 adults in the US. And the symptoms are maybe overweight, obesity,
Well, I don't know if I can raise the volume anymore, man. There's nothing really I can do about it. It was more because I'm doing a screen share. The only other way I can get this louder would be to rip it and then to put it directly into StreamYards. But I mean, or I can turn up my volume. You might get some echo as it comes through my mic. So, but if you can hear it a little bit, it's good.
belly fat and high blood sugar, high blood cholesterol, and high blood pressure.
I mean, you're really describing a bulk of the population. I mean, let's be fair.
Yes.
Right?
So almost anyone who is watching it may know someone who has one of these symptoms.
Okay, so you had a study done at the Salk Institute. Talk to me about that.
Yeah, so this study was done in collaboration with Dr. Pam Taub, a cardiologist at the UC San Diego Health. For over 7 years, we knew in animal studies that if animals eat all their food within 10 hours window, then they're protected from metabolic syndrome. And we wanted to see whether it really works in human. So we did this study only on 19 metabolic syndrome patients. This is the first step to see whether it works in a small population of patients.
And did it?
So these 19 patients went through a 3 months, what we call 10 hours time restricted eating. It's also popularly called intermittent fasting. So people had to, the only recommendation we had was they had to choose their own 10 hours and eat all their food within that 10 hours every day consistently. They cannot just move that 10 hours window. And to help them track when they're eating, they could also use an app called My Circadian Clock. And anyone in the world can actually go to the website, My Circadian Clock website, sign up and use the app. So within 12 weeks, after 12 weeks, when we brought these patients, we saw many improvements. One thing I must tell you is most of these patients were already taking at least one medication to control their blood cholesterol or blood pressure, but they were not getting enough benefit from the medication. But after 12 weeks, what was surprising was almost all of them lost some weight, mostly their belly fat, and many of them, they controlled their blood pressure much better, their blood cholesterol also lower. Few of them, 12 out of 19, also had high blood sugar in the morning, and they saw significant improvement in their blood sugar. So we're very excited about this study.
Talk to me about the science. I mean, if you...
So basically, these people corrected their metabolic syndrome just by restricting the times in which they eat. It's pretty simple. I mean, and it's actually natural. Like we eat in our society, in westernized industrial society, we eat around the clock. I mean, and you can maybe do that with certain things like fruit or whatever. But generally speaking, there has to be time of metabolic rest. Your body at night is trying to repair itself, and you need to give it the time to do that, and not like eat going to bed, because when you do that, then it's got to process food while you're asleep, and that's something that's not supposed to be doing, right? So, did they use a tin can and string? Yeah. Yeah, he is soft there. I see there's a couple videos over here too. This is a pretty good one. I remember watching a few years back, I believe. Oh,
So the way I would like to introduce.
but I'm not going to play an hour-long video. But also, guys, if you don't know the Salk Institute and how prestigious they are, you should look up them and their findings on the vax and such. Good read. Good reads. Things I'm not allowed to talk about. And see what here. So the difference between time-restricted feeding, intermittent fasting, there's not really any as far as I can tell. But we'll see what he has to say here.
People may be confused.
And this is Rhonda Patrick, by the way. Show her little Found My Fitness. This is clip, so I guess this is another channel.
By this time-restricted feeding, which is essentially, feeding within our active hours, the daylight hours, and intermittent fasting. So there's obviously some overlap between the two, because if let's say you're feeding within a 12-hour period, so you wake up, you have your first sip of coffee, that starts your clock. All right, that's it. So 8 o'clock, then you better stop eating by 8 p.m. Right? That's for 12 hours.
Yeah.
Then from 8 p.m. all the way till 8 a.m. the next morning, you're fasting, right? You're not getting any energy.
Yeah.
So in some ways, you're getting a lot of, there are some overlaps between this time-restricted feeding and intermittent fasting, for example, which has been shown to increase ketone bodies like beta-hydroxybutyrate, which I know you've also shown restricted feeding does increase that as well. Takes around, I think, 10 to 12 hours for your liver glycogen to deplete. Fatty acids get immobilized. They go to the liver. You start to make beta-hydroxybutyrate and other ketone bodies, which then get transported to other tissues and are used for energy in the brain, or they act as signaling molecules.
So let's read this real quick, because this is just for your knowledge. A ketone body that is synthesized in the liver. This is beta-hydroxybutyrate. This is the primary one that the people who are in ketosis are looking for. And guys, you should be in ketosis at points in your day of living, your 24-hour period. In fact, when you're sleeping, there's a period when you should be in ketosis, quite a long period, actually. This is good for you. It's what you're supposed to be doing. But when you're eating all the time, these hormone signals are turned off, are the appropriate hormone signals, and then your body's doing other things that it shouldn't be doing. And these are natural processes that are supposed to happen nightly. For instance, just a simple one, off topic here. When you sleep, if you sleep on your back, during that period, cerebral spinal fluid is being flushed out of your brain and to the spinal column and coming back up. And that happens to basically remove all the junk and debris and particles that have been released around in your brain and the bloodstream up there that needs to go away. And then it comes back in with new fluid. You can think of it kind of like a transmission flush or something in your car, right? So if you lay on your back, this does not happen very effectively and efficiently. If you sleep on your side, though, it does. So we can tell, or you can infer, that human beings are meant to sleep on their side, or even, I don't know of any studies yet about people on their stomach, but potentially even their stomach, for this process to happen of cleansing in your body and detoxification. These are all very important things that if you want to live a generally healthy, good life, or at least when you're old, you want to be functional, you want to have your brain, right? This is part of the low insulin thing, because Alzheimer's is essentially a disease of, oh, that's not it. Hold on. Oh, here we go. A disease of your brain having diabetes, more or less. Bad insulin sensitivity. And there are many many things that tie insulin to longevity. So, but anyways, beta hydroxybutyrate is synthesized in the liver by acetyl-CoA when fasting or in ketosis. It can be used to produce energy inside the mitochondria and has also been shown to act as a signaling molecule that alters gene expression by inhibiting class 1 histone. I'm not familiar. Deacetylase. So that's the allase says it's an enzyme and would break things down. But in any case, the important thing about this is that beta hydroxybutyrate can cross the blood-brain barrier and fuel your brain. Otherwise, it's totally glucose dependent. And most people will tell you, most people who know some nutrition or medicine will tell you that your brain operates off glucose, and that's not true. I think it only needs like 20% of it needs glucose, and the rest of it can operate off of ketones. And trust me, when you're in ketosis and that's going on, your brain is going 1,000,000 miles per minute. It's pretty awesome. You have a lot of clarity. A polysaccharide, glycogen, is a polysaccharide molecular similar to starch, consisting the principal carbohydrate storage material in animals and occurring chiefly in the liver and muscle. This is the only place it can be stored, is liver and muscle, and your muscle doesn't release it to be used in energy anywhere else. It is only directly in those skeletal muscles that are, used to lift your weights or open the car door or pick up your baby or whatever you're doing that's moving your body. All right. And then the liver can release some into your bloodstream if it needs. Glycogen makes up about 5 to 6% of the fresh water of the liver and around 1 to 2% of the muscle mass. The amount, and this is also why if you cut back on your carbohydrates for a while, like bodybuilders do, right before they go on the show, you'll look really lean because you'll get all the excess water out of your system because those molecules attach to water. It says the amount of which is affected by things like physical training, basal metabolic rate, and eating habits. And of course, fatty acid, I'm sure you guys can figure out. That's pretty basic.
Yeah. Which Eric Verdeen at UCSF.
Yeah.
So, and there's lots of.
Ketosis is a state in which your body is using ketones, which are produced basically from fatty acid ingestion, and they're, I don't want to get this wrong. I actually probably should look it up to get into it precisely, but they're basically, like it says here, ketone body is synthesized in the liver from acetyl-CoA. It's basically a form of usable fatty acid for your body to use for fuel, because what your body does is it transfers and turns things into different molecules to be used all the time. For instance, a lot of the sugar that your body uses actually turns into alcohol in your system, forms of alcohol or sugar alcohols, and is used that way for energy specifically. So, but again, I know these things, but I don't work in this field. So I'm not like Rhonda Patrick, where I can rattle these things off the top of my head all the time, because I'm not talking about these things all the time in my life. They're just not that, clear for me constantly to rattle off. But in general, yes, I understand what she's talking about, or can understand reading these things. And I take it for granted that folks like you might not know what that is, Spook. So.
Can you first of all differentiate for people, like the difference between intermittent fasting and time restricted feeding? Like what are the main differences, and maybe what some of the similarities are?
Well, both of these depend on this idea as the commonality is this prolonged period of fasting. When I say prolonged, that's usually longer than 6 to 8 hours, because that's how long it takes for glycogen to deplete, or maybe the fatty oxidation to begin, so that we begin to use some of the fat. And you also pointed out ketone bodies and beta hydroxybutyrate; those are also produced maybe after 8 to 10 hours. So,
so here she's got this up here. I'll just read it for you. It says the Molecules that are produced in the liver by the fatty acid during periods of low food intake, fasting, carbohydrate restriction.
The bottom line is this: there is
I know that was up there before. Here we go. Carbohydrate restrictive diets, starvation, or prolonged intense exercise. Ketosis is something that they medically found basically to treat epileptics back in the day. And it's essentially how the Atkins diet works. It's the principle in which it works upon paleo, all these other things. Paleo doesn't necessarily have you in ketosis all the time, but you should have some ketosis in your life regularly, like I said, daily. And the doctor right here is saying that. Examples include acetoacetate, beta hydroxybutyrate, and acetone. These ketone bodies are rapidly used as energy for a diverse array of cell types, including neurons. And that's the thing, is you need the proper energy for the proper cells. And so these things, if they're not being fed properly, they're going to die off, right? They're not going to function. The myelin sheath on your nervous system, it needs vitamin B12, if I'm not mistaken. I think B12 and 6 are the two primary ones. Anyways, if you're not getting sufficient amounts of that, your literal nervous system is going to be breaking down. So again, we don't talk about generally diet in these kind of ways. We don't talk about our health like this. Like how can I prevent my car from breaking down? Well, if I wanted to keep a car forever, right, there's eventually going to be some rust damage. That's oxidation, right? But I can still replace parts of it. You know, I can still do things to it. Your body does that internally when you have oxidation, right? I can change the engine, but again, the body of the car, the underbelly, and maybe even the carriage is going to have some rust and stuff on it. Well, I can scrape that off, or I can replace it, or do whatever over time. And that's what your body's constantly doing, unless you're not giving it the correct circumstances to do that in. So anyways, I'm going to shut my mouth and let this video play, and then I'm going to get out of here, guys.
10 hours. So the bottom line is this: there is, when we eat, we have a type of physiology where we're using glucose and we're driving some bodily function. And at the same time, we may be also damaging some cellular components because of all the reactive oxygen species that we generate during eating, during metabolizing all of this. So all of these have to be repaired, and for some reason, we do not know why, the repair mechanism happens only during the period of fasting. And during this period of fasting,
so again, he's taking reactive oxygen species. These are the things that are damaging the DNA.
we switch to a different kind of metabolism. Just like you said, our primary energy source is not the readily available glucose from food anymore. It has to come from different sources. In some cases, it can come from a little bit of protein, that's gluconeogenesis, or from fat oxidation, or just like you said, ketone bodies. So these things, this physiology, the fasting physiology, we actually know, we are just seeing the tip of the iceberg of fasting physiology. We're just learning about a very few molecules. We don't know what happens to a lot of signaling molecules, how the mitochondria actually repair during fasting. Is it actually necessary?
There's a lot of stuff that goes on, including your growth hormone levels increase significantly while you fast. The longer you fast, so if you fast for several days, testosterone, surprisingly, goes up for a little bit and then kind of flatlines. It doesn't completely shut down, unlike what people tell you. You're not going to eat your muscles if you fast. That's silly. Now, if you don't eat anything for 2 or 3 months, yeah, you might look a little anorexic, and it might start tapping into your muscles. But generally speaking, you don't have that high of protein turnover in your body unless you're doing very strenuous activity. But I'll save fasting for another time. I'll come back next Thursday with some more of this. Let me get my mouse over here. Because I think it's really important. People don't understand how important the insulin signaling is in your body and how it can be detrimental to your health over time. Um, and how having low insulin levels and low insulin sensitivity are primary markers for longevity in your life. And, granted, I'm a pretty young looking guy for a guy my age. Part of that might be some genetics, but generally, I think it's because for the most part, other than a few bad habits I have, take care of myself. I get appropriate collagen and protein. Collagen is protein, of course, but it's a specific type. I get plenty of nutrients. The one thing I do lack in generally is good sleep. But aside from that, I've been intermittent fasting for well over 15 years. So doing time restricted feeding, and I don't even do it all the time, but I do it most of the time. And I've heard Rhonda Patrick talk about it in the past, where she or Dr. Panda there that you can even do it for you can even cheat 2 nights a week, because the one of the studies that they did at the Salk Institute, I actually participated in for a little while, because they had people taking photographs on their phones through an app, and I think they might still be running it. But they wanted to see when you ate and what times, and it was just part of their studying of this time restricted feeding stuff. So it's pretty cool. Elbow cough. You guys arguing in the chat or something? How's it been going, Bill? I'm gonna have to catch this on the replay. Yeah, that's cool, man. Yeah. Thane, for your understanding, I'll be streaming at 4 p.m. Mondays, Thursdays, and Fridays, and at 3 p.m. on Sunday, and Sundays will be probably 2 or 3 hour long streams. So since I'm back, since the strike has expired. In any case, guys, I appreciate y'all being here. Thank you so much for joining me. And all of the nice comments, including the not so nice comments from people, trolling, doing the stuff, doing the thing. And I will be back tomorrow. We'll be talking about Stoicism and Christianity. And we're going to be talking about that for a while on Fridays. So, guys, thank you so much for being here once again. Hit that like button, subscribe if you're new and you enjoyed this. And I will catch you all tomorrow. And I guess I got to say it. This has been AllMinusOne. My name is Bill, and I wish you all well.